Okay. Last module of the 3-day class. Let's deploy applications. So introduction to DevOps, this cracks me up. DevOps is now 13 years old, but like the Agile Manifesto, we're still kind of really trying to figure out how to make that work, right? And like Agile, DevOps is not always the answer either. So, I work as a DevOps advocate a lot, so and mainly around business transformation and platform transformation. But yeah, I don't know. There's a lot of challenges there. It's always about people helping people. So we're going to talk about some deployment, some testing strategies, including deploying applications with Beanstalk, and then that's it. We're going to move into the lab. I am going to post the survey before you move into the lab, and at that point in time, you get to go do the lab. When you're done, you're done. Otherwise, you get to hang out with me until 5. So let's talk about DevOps first. So I actually think this is a great statement, is that a product, I think, is a good way to say this, includes the application plus all the environment that the application needs to run in, right? In other words, if you want your application to function, it's not just the application code, it's also the environment the application needs, right? That could be adjunctive third-party services, it could be logins, it could be logging, it could be monitoring. Last time I saw, there's like 27 concerns that operations has to solve the minute you put any new technology into play. So when you put Windows into play, there's like 27 problems that operations has to solve, right? And if you throw developers in there, there's another 27 challenges, like logging, monitoring, how do you deploy it? How do you provision it? How do you update it and patch it? How do you maintain, like all those questions, like people don't think about. They're like, well, it's just a Windows box, let's just launch it. It's like, well, if you have one Windows box, you might as well have 1,000, honestly, because at that point in time, you still have to solve all the security patching, maintenance, whatnot. You throw applications in there, you throw a database in there, you throw other technologies in there, you still have to solve those same 27 problems for every technology you throw in, whether it's at the application stack or whether it's at the infrastructure stack, doesn't matter. Same problem. So this is like, people just say, developers and sysadmin, cats and dogs sleeping together. Let's just be clear, like the original sysadmins were all coders, right? The difference became, it wasn't about like skill and capability. The difference became is that the operations didn't want people to make changes because they got woken up at 3 o'clock in the morning, and developers were like, I need to go fast. It's not Ricky Bobby syndrome. I don't want to go fast for going fast. The business is leaning on me to push out features that drive innovation, that drive revenue. And in the operations is like, well, I need stability because I need customers want our reputation. They want to be up so they can like consume these features that you want to deliver. And there seemed to be a conflict, but the truth of the matter is that it's just the business applying pressure on different sides of the equation. So DevOps's goal was to break down the silos that basically prevented from all these teams working together, because at the end of the day, we all want the same thing. If you're working for a business, it needs to make money so you can get paid. That's really the thing. Now, hopefully you've got some additional like cherries on top of that sundae, and you're doing meaningful work and it's challenging and you love who you're working with, and you're not working for somebody who's super mean, like, or overly controlling or micromanaging like a boss like that. And hopefully that means that you're not only getting paid, but now you get to not just survive, but you get to thrive by having this great experience. That sense of communication, collaboration, being proactive, like skilled at your job, like that kind of thing, that's all part of the DevOps kind of cultural battle cry, which says, what can we do to remove any barriers that lets us as a team deliver great software, whether those barriers are internal communication barriers, external lack of understanding, using the wrong technologies, not being able to adapt, et cetera, et cetera, et cetera. Doesn't matter what the barrier is. DevOps' goal is to break down any barriers that prevent you from delivering, hosting, and running software with agility, speed, and compliance. Notice I said agility, speed, and compliance, because if you run insecure software, you might as well just go ahead and open your front door, which is why DevSecOps has become popular, right? Because leaving security out of the equation is like baking a cake without eggs. You can't put it in afterwards. In many cases, it's really expensive. You just have to rebake the cake. I also love the newer emergent, what is it, the DevSec MLOps? When now it's like machine learning operate. I mean, at this point, can we just agree that we're all in the same boat? We're all trying to accomplish the same thing. This is actually what DevOps is about. Is we're all in the same boat. We're all trying to accomplish the same thing. How can we do that together, right? Now, Agile and DevOps do actually go together really well. DevOps typically fits inside of an Agile mindset because Agile tends to be a little bit more strategic about the software development lifecycle. DevOps is a little bit more interested in the deployment, delivery, and build cycle, typically, right? I'm not limiting anybody, but that's typically the case. So then how do we break down these silos, right? Because it could be just a cultural philosophy, but in practice, it is the implementation of certain concepts, such as repeatable infrastructure, because guess what? Developers are writing code that can be repeatedly compiled to build an application. Now, I know some of you can make fun and say, well, that's if the test pass and whatever. You know what I'm talking about. So what if we just had operations do the same thing, right? But that also means, by the way, that, you know, DevOps people are very interested in what happens at the front of the build cycle because they want to alleviate concerns upstream, right? They want to solve security problems upstream. They want to solve scalability problems upstream. They don't want to do it once the thing's launched. There was an industry average metric that said you're going to spend about 4 to 10 times the money that it took you to get to day 0 of production deployment. You're going to spend 4 to 10 times that money after you launch to maintain, keep it up, patch it, etc. What if you could reduce that down to 2 times by solving upstream problems? So practices like CI/CD, infrastructure as code, using microservice design, but also other like more human things like visibility, transparency, you know, shared responsibility, everybody coming together, not just dev and ops, and then using tools that give visibility, that solve upstream problems, right? And it might slow you down a little bit, but imagine if every single piece of software you deployed didn't have a flaw in it, didn't have like a critical flaw. It scaled, you could get monitoring and telemetry metrics. You might think, well, Michael, that's like, we don't really want perfection. We got to deliver. Yeah, I agree. I'm not talking about perfection. Just talking about a little bit of excellence, a little bit more, a little bit better, right? That's all, not perfection. So DevOps really focuses on the basically people, process, and tools, which you could argue, by the way, is the cultural philosophies, right? That's the people thing, the process, which is also the practices, and the tools, the technologies that you're using, because they can make a difference. They can also complicate your life. Just depends. So people, processes, and tools really make up the core of what DevOps is about. How do we improve how people interact? How do we improve our processes to make them bulletproof and human-proof to a certain degree? And then how do we choose the right tools and technologies to enable these things to happen without overcomplicating our lives and having a buffet of languages or a buffet of operating systems or a buffet of providers? Remember, simple is fast, complex tends to be slow. Now, with that in mind, you know, there are traditional phases that usually come, like what, you know, when you're like going to build something. Like this is like a release process, right? We're going to check in the source code, you know, depending on whether you're using Git Flow or GitHub Flow, trunk-based development, doesn't matter to me. You might do peer reviews, but just to point this out, peer reviews are a manual process that slow things down. Maybe instead you do pair programming, which you think is like, oh, that's a waste. Yeah, but imagine if you didn't have to do peer reviews, because with 2 or more people, you're going to catch your mistakes. So you've already got a senior person looking at a junior developer's thing. Knowledge gets to rub off of each other. The old crusty guy gets to be enthusiastic with the, you know, the young new person who's come in to the field. I'm just saying, maybe I've been the old crusty guy. You know, it's fun. So first you got to source your files. Where's this going to come from? Where's it going to committed? What's your release branch? Then there's a build process. I'm assuming, by the way, if you're going to do a merge at source, somewhere between the source and the build process, you're going to test your code somehow, maybe lint it, do some syntax checking, unit tests, I don't know, right? Code metrics, maybe create some images at this point in time. Bottom line is that when you're done with the build process, there better be an artifact. Otherwise, you didn't build anything. Some kind of artifact. It could be a zip file of Python, jar file, binary, I don't care. Then what happens is you take that binary and you run it through your environments. Hopefully there's a dev environment. Maybe there's a QA environment. Maybe there's a staging environment. Maybe there's a UAT environment. God forbid you actually have a load testing and performance environment. I just say that because most of us are under, right, under like date driven pressure. So we don't necessarily have the chance to do this stuff, which is unfortunate because then we do it in production. So like the funny thing is like I tell people this all the time. It's like, look, if you don't want to do load testing now, you're just going to do it when you get into production. Do you want your customers to load test, or would you rather load test? And like, we don't have time for that. Okay, great. Sounds like your customers are going to load test. Let's go ahead and shove this out and see what happens. And then when it falls over and goes sideways, I never ever look at them and go, yeah, I told you, because I don't have to. They know that I was like, look, this is either going to do it upstream or you're going to do it downstream. You don't get away from it. So if you don't have a failure, by the way, it's because you just got lucky. Is that how we operate? Anyway, test things first. And that could be load testing, security testing, all kinds of tests. So you've sourced it. So you've done your merges and your code repository so that you build it. That leads to an artifact. You take that artifact, you run it through a couple of different environments. And then if you're feeling good, you push it out to production. That, by the way, that whole process of integrating the everything in the code base, that's continuous integration, where you're continually integrating into a deployable branch inside your source. And then once you go through that process of testing, like building the artifact and testing it, that's called continuous delivery. That's not continuous deployment. You know why? Because you're stopping your delivery right before you get to deployment. If you automatically deploy into production, that's continuous deployment. So when people say CI/CD, most of the time they're doing continuous integration with delivery, which means they stop right before they get to production. If you're doing continuous deployment instead of continuous delivery, you are automatically delivering into production every single time you do a build. Google does it. I say that Google does it. Does that mean that we can all do it? No, it doesn't mean we can all do it. It means we all wish we could do it, right? So then you deploy into production environments, and then guess what happens? Someone's got to monitor, feed, maintain. You got to get telemetry. Is it failing? Are half your users having a bad experience? Are you all of a sudden seeing revenue drop off? Have a bunch of people logged out of your site? Do you know, or are we just getting lucky? A lot of people, by the way, run this whole process off of guts and glands. I don't really have to explain that. The bottom line is that without metrics or data, you're not really going to know what's going on. So at every stage of this, there should be a metric. Hey, everything compiled and tested. I now have a deployable branch. The deployable branch built an artifact. The build works. I ran through all my testing environments. Looks great. I deployed to production. 0 errors. Hey, I'm still in production. Everything's up. Everything's working. Customers are happy. Load average looks good on the systems. No unusual activity or errors. So these are the like typical phases, right? Now, people will use different names for these phases and whatnot, but this is pretty standard. Any questions about this before I move on? This is a reminder. I think honestly that arrow is a little too far. Continuous integration probably does go up to the build process. Maybe that's not too far. Maybe that's pretty accurate. Sometimes I like to think of it as just the merging, and then somewhere in there is this fuzzy gray line of, do we actually build the code? Probably need to build it, right, in order to test it. So I'm probably okay with that arrow. But then the rest of this, by the way, is continuous delivery. Now notice that the arrow goes all the way to deploy. That's not what happens. Continuous delivery should go back actually to, because you're not deploying into production with continuous delivery. Notice that little gate there. That gate is the manual approval process that most companies put into place that says, well, we just want to pause for a second before we push this into production. So most people are doing continuous delivery and they pause right before they get to production. Continuous deployment is that we're just automatically deploying into production. This allows people, by the way, you can automate this whole thing if you want to, including the rollback if monitoring shows that the deployment is failing. Like Google, as an example, when they roll out like a feature for Gmail, they roll it out to about less than 1% of their customers first, this is after it's all been through testing. It hits a small portion of their production servers. And if the errors don't show up, then it keeps increasing the amount of production servers it's on. As long as the errors are below acceptable limits, keeps going, feature gets rolled out. They're doing this all the time. So this is how they roll stuff out into production, is the minute errors start showing up, they'll actually roll the deployment back automatically. Here's another kind of like variation on continuous delivery. So developer is going to commit to repo, right? Then what's going to happen is that there's going to be like a CI/CD server that's going to pull the code and then pull it back. It's going to do things like, do some building. It's going to send a report to the dev if something fails. Say, hey, by the way, something went wrong. Nothing fails. It's going to build the artifacts after the code merge. The artifacts are like the jar file, the zip file, whatever. And then what's going to happen is going to push it to a package builder. It might even grab some configuration from the original version control, build whatever deployment package needs to be built, and this is going to store those packages in an artifact repository. It says repo, they're not the same. An artifact repository does different things, like stores third-party libraries, stores container images, stores npm packages, stores Ruby gems. So this is where this stores packages. So that's an artifact repository. That would be code artifact, not code commit. Version control is a get function. You could use a repo to host your libraries, but most people use something like Nexus, Artifactory, what's called an artifact repository to do this. This whole thing can be integrated. Does anyone kind of like, I have never seen any idea or concept like this before. And we need to peel any of this back. Okay. I mean, it's pretty standard, but I just want to be accommodating for people who may have never seen this before and are like, Michael, I don't know what you're talking about. Okay. What if you have a more complex environment, right? You need to deploy, for example, infrastructure, which is what DevOps advocates, is that deploy your infrastructure the way you deploy applications. Put it into a file, check it into a repository, use linting, syntax checking, write your tests, do TDD and BDD first before you write the actual output. That's all super common, right? Like do this along with your application. That way, by the way, you could build the infrastructure first, then deploy the app. And then when you need to make a change, you change the code for the infrastructure, which may add more servers or whatnot. Now, if you're using auto scaling and on demand and that kind of thing, it'll just do that for you automatically. But I'm talking about when you want to make a major change to the infrastructure, like you want to add a search engine in, like you want to add Elasticsearch because you need to add search capability to your application. That's infrastructure. You add that in, right? Or you need to make it across 2 availability zones, or you need to make it DR capable, like that kind of thing. Just do that with the infrastructure as code. Don't go in there and manually start clicking things. Now, I say that, I just want to be clear about this. I wish there was a world in which you could click through the console interface and it would generate a code file about what your clicks actually did to the system. That would be real click ops. I wish that we would get to that, but we're not there. We have to write code now in order to get our operation stuff to provision. Kind of like the low code, no code environments that you see emerging for developers now. Now, the code services are meant to support all of these different stages, which, by the way, we do want our infrastructure as code, honestly, to follow these different stages. Even if it's Terraform, it doesn't have to be built. We can still test it, run it through test environments, build a test environment, see how it functions before we start messing with production. We can still do those things, actually. Everything that we do in the software engineering discipline, we can apply to infrastructure engineering. We could do that same software applicability. These services, some of which you've seen before, like X-Ray and CloudWatch, these services allow you to have a Git repo, build an artifact. Testing, by the way, you're probably going to do in the build artifact or in code pipeline, which code pipeline will orchestrate most of this for you. They're going to deploy it using code deploy. And I just want to point out, code deploy will run both on on-premise servers and in AWS. So you can deploy using code deploy. Just so you know, a lot of the AWS services will work with on-premise servers. People don't know that. Just letting you know. By the way, CodeStar is at the top because it'll orchestrate this whole thing for you from end to end so that you and your team can just code and not have to worry about the whole pipeline thing. So just know that CodeStar is up there. Most people don't know about it. It's an orchestrator to just like set this whole thing up for you. By the way, you can throw third-party tooling in there. You want to throw Jenkins in the middle of these code services. You want to throw GitLab in the middle of these code services. That can all happen. But just be aware, code commit is a Git repository. Code build is used to build like code artifacts. Code deploy is used to deploy code, built code artifacts. By the way, code artifact is missing off this page. Code artifact is a service AWS offers to host the artifacts that you deploy. And code pipeline will orchestrate most of this, not all of it. CodeStar will do all of it. X-Ray and CloudWatch, you already know. X-Ray is used for tracing. CloudWatch is used for metrics about your infrastructure and deployments. Excuse me. Questions? Cool. All right, here's a few like testing strategies. These are ways to deploy that you should think about. They are going to ask you questions on these. All right. I think everyone's at this point kind of heard of a blue-green deployment methodology. It basically says, I have a blue environment. This is where my version 1 production runs. I have a version 2 environment of production called green. I want to move all my traffic from blue to green. DNS, load balancers, global accelerator, those are all services that will allow you to just flip over. If you're using Beanstalk, by the way, which is a wizard for EC2 deployments or other deployments, but I'm just going to simplify that. It will handle that DNS change for you. By the way, DNS and AWS will also do weighting. So if you want 20% of your traffic to go to green and another percentage to go to blue, that's actually typically called a canary deployment, just so you know. But blue-green is when you just cut over. You're like, right? If you have a problem with green because you find a bug, you just cut back to blue. Right? Here's some variations on that pattern. Notice here that there's 100% on the blue side on the left-hand side and 0% on the right-hand side, which is the green side. The right picture on the right flips that, says we're going to just cut over. When it does 100% flip like that, it's typically known as a blue-green deployment. If it does steps, stages, like little bits, it's usually known as a canary deployment. If it does it over time, it's known as a linear deployment. Meaning like every 5 minutes, it moves 10% of the traffic over. That's like a linear deployment. Canary is when it's like, I'm going to stick 1% of my traffic here. Is it all good? Let's stick it all in. Canary is like really shallow. You stick like 5% of your traffic in, and then you just move the 95% over. Blue-green is when you cut cleanly over between 100% and 0%, right? This is actually being done when you got 2 ELBs that have complete copies of the environment with just different versions of the application. This one is interesting because this is where you have an auto-scaling group and it's got 4 instances on the left-hand side. And what you do is you slowly start adding instances into the equation. And those instances have the new software on them. And the load balancer focuses on the 4 new instances and phases the old instances out. Right? That's also one way to do it. So what you do is you just request that the auto-scaling group be set to double its usual capacity. New instances are going to be created with the new software, and then set the auto-scaling group back to its original capacity, which of course causes the old instances to be terminated. This is a really simple way to do it. Most people don't do this, by the way, because it's not as easily orchestrated as like a blue-green deployment, but it can be done with a load balancing group. Some people do this, for example, with Kubernetes. Like with containers, imagine these are containers, like you roll out new containers, right? Other ones, but just to say this, out of the box, Kubernetes typically does a rolling update where it adds one and removes one, adds one and removes one. It just keeps like doing that. So it's hard to roll back in that. You just have to redeploy the old software. And then I mentioned the A/B deployment strategy, sometimes known as canary, right? You get a little percentage of traffic, 5%. And then when everything looks good, you're like, I'm going to roll it all over, right? So remember, blue green is just 100% cutover. Linear is when you like are doing a percentage every couple minutes, like at a certain time frame, like 10% every 5 minutes. A/B testing or canary is when you put a little bit of traffic on the new environment, see how things go, and then move everything over, right? You don't stage it, you just go. A lot of people do linear now, just so you know. It's like they just 5%, then 15, and then 25, because everything breaks under scale. At what point? It just depends on how much traffic you have. Okay. Any questions about the deployment strategy, CI/CD, DevOps, or any of the code services, just from broad strokes? Okay, so a good way to get started with application deployment, especially if you don't have infrastructure chops, is to use Beanstalk. Beanstalk basically is a great tool. It offers a number of advantages for developers, right? To basically put a wrapper around lower level services like CloudWatch and auto scaling and all that stuff. It just sets it up for you. You just pick the environment that you want to run, answer a few questions. And by the way, a few questions could be 100 questions, just so you know. You can get really complex. If you want to add a database and add you could answer a bunch of questions, or you can just answer a few questions, whichever you want. But this basically allows you to deploy your applications, and you can retain a decent amount of control over your infrastructure. So for example, if you got some code you want to run, you got an HTTP server, an application server, need control over the OS, Beanstalk will allow you to make those choices, and then it will set it up in AWS in a best practice way for you. That includes failover, blue-green deployments, that kind of thing. Like it will do those things for you. Now, if you want to do like a Tomcat server or a web server, if you want a single instance or multiple instances, you want a development version or a production version, you can set all that up. It does store your deployments in S3, and it will roll forwards and backwards based on what's in S3. So you have a lot of control here. You get to do a lot of things, whatever is of interest to you. Now, this is not highly customizable. So if you got some kind of unusual configuration, or you want to just add like an additional database or whatnot, some of that you might have to create outside of Beanstalk. I will tell you that Beanstalk does generate some cloud formation, but in general, it's not like a infrastructure as code repeatable build process. So, but it does convey a lot of advantages, especially if you have to use virtual machines. Here's an example where you've got two versions of code. You've got a test environment under version 1.2, and then you've got a production and a staging environment, and that's on an older version because you're still testing 1.2. Notice that the AMI IDs are different between the two versions of like application, and even the PHP versions are different. So there's 3 environments. So you can have multiple environments for a version of code. So this allows you, by the way, to have test environments and QA environments and staging and stuff like that. And then you could have, a development environment, a test environment, UAT. You can do as many as you need, as many as you're willing to pay for. Now, the cycle with Elastic Beanstalk is that, first of all, you initialize it, then you create your infrastructure. There is an EB command line, right? And you just like initialize your application using Beanstalk. This is going to create a .elastic beanstalk folder with a config.yaml inside of it that's going to be in your directory with information about your application and its environment. Then basically what's going to happen is if you do an EB create, it's going to start a Beanstalk application out there with EC2 with a DNS endpoint, and then it's going to like create the environment, if you will. And then deploy is going to allow you to redeploy versions of your application. Now, don't be fooled. These commands, by the way, require several arguments. If you do not provide the arguments on the command line, the CLI is going to prompt you, what AMI ID do you want to use? Do you want single box or multi-production? Do you want auto scaling? Do you want to turn on DNS? This, by the way, does also offer Git integration and the ability to launch applications from a special Git branch. So you can create a branch, make a series of changes, and then test your changes in the live environment just by getting the CLI to read that branch, like a test branch, for example. Cool service. People don't stay here, though. They start here. Now, just like Lambda, Beanstalk requires two roles. One is for Beanstalk to create resources in your account, and the other is what permissions the resources have. So think of the service role as the invocation role. Like Beanstalk's going to invoke a bunch of other services to create resources on your behalf, and the instance role is actually the permissions that your application has, right? So one is used to create the infrastructure, and the other one is the permissions that the infrastructure has itself, right? So when you run EB create, you got to specify the roles in question as well. If you don't, by the way, supply the roles, Beanstalk will create them for you. I know. So it's based on your user permissions. So if you don't have access, you won't be able to create the thing. So for example, your application uploads data to S3, you can add these permissions to the role created by Beanstalk, or create and use a new role and associate that with the service in question. So you can customize the default environment, like if you need to like add library dependencies or whatnot. You're going to use the environment configuration file. This does show up on the exam. Hold on just one second. There we go. I just wanted you to see this. Is that EB extensions config.yaml? This is actually created not when you do a create, but when you do an EB init. This contains things like downloading packages, configuring the defaults used for services, changing runtimes. This does sometimes show up on the exam. Is that if you needed to change like a library dependency, they're going to change the config.yaml inside of .eb extensions. This does show up every once in a while. Here's an example of the config.yaml, by the way. So options that can define environment variables on your EC2 instances, such as bundle without, the rack environment, values around production, namespace, application health check URL, right? This looks like some kind of, it's got to be like a Rails application. It's using Rake, although Rake doesn't have to be used for Rails, but I'm suspecting it's Ruby. So option settings, by the way, enable you to enable like two types of values. The first values are basically arbitrary or application like specific, such as environment variables, what you want on your EC2 instances. These can be used to like assist your application, like what database to use, where do I get my S3 packages. The second values are options that apply to other components in the stack, such as load balancing, auto scaling. These like have a namespace, which you can see there, plus an option name, plus a value. Whereas the other options are really just like environment variables. So there's two types of like data sets inside of this section. Packages are going to get installed on your instances. Like in this case, it's going to use Red Hat, I'm assuming, because it's using Yum, and it's going to install Git. And then if it's got containers running, like some commands like run rake generate secret token. Again, you got to read the documentation if you really want to dig into this. They're not going to ask you questions about the option setting that I've seen. Now, there are a couple of different ways of deploying. First of all, they can do an in-place upgrade. They can also do what's called an environment swap, where basically you clone an environment and then point your DNS URL. It's like blue-green, right? You go from one environment, you go to the green environment, right? An in-place update, by the way, one at a time, the machine basically it replaces and updates the software. Hard to roll back when you do that because then you got to redeploy the old software. With an environment swap, you can just cut back to the old environment. One thing I wanted to show you. Sorry. I am frustrating myself by not staying logged in for some reason. Yeah, wow. I wonder why I did that. Bear with me as I log back in. Anyone have any questions while I'm doing this, please feel free to ask. Dun, 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 dun. Let me show you, by the way. I just don't, oh, go ahead.
When you switch environments like that, from blue green, what happens if you're in the middle of a session per se, and your session variables and those things that you might need to log on to your account? When those get affected in a way, or in the sense that, oh, I'm in the middle of a session, but all of a sudden I have to log out and log back into the system in order to start over again. When things be affected if you just switch like that?
Well, so one thing that commonly pops up is that like the data stores that feed your application frequently are outside of that application swap, right? So if you're storing your session data, which ideally you are, in a data store that's not part of the Elastic Beanstalk application deployment, then when you roll over to the new environment, it's just going to pick up the session information from the data store.
Of course.
Yeah. So that's the recommended reason why session state should ideally never live on your applications. Is for those kind of scenarios. Yeah. It sounds like you get it. So this is Beanstalk, by the way. I'm actually shocked that these are here. Look how old this is. Now, this one I'm not shocked about. This was an Nginx test, but the 2016 one, I'm like, really? I didn't know you were here, man. You've been here since 2016. You know what that is, Michael? That's poor account management right there. Anyway, it's my demo account. So anyway, so this is the Nginx like test environment, right? Now, it has no environments in it. There's actually nothing here, right? And so technically I could probably delete this application, which, probably should do at some point in time. But I just want to give you a sense of what Beanstalk will do. So for example, let's say we're going to create a web app, and this is just dev test, and I'm not going to put any keys in there. This is where you get to choose your platform. Now notice it shows Docker, Go, Glassfish, Java. There are like specific runtimes you can use, right? So let's say I'm just messing around and, I'm just gonna, say I just do Java for a second. Now, by the way, Corretto is Amazon's own JDK that they've done because, Oracle's gotten weird. What a surprise. Don't get me wrong, I love Oracle. And by the way, they have a great cloud infrastructure. Do not say I repeat that. But they're such a weird company sometimes. Anyway, here's deprecated, but then we got Corretto here. So let's say we run 11. And I'm going to use the latest platform version, and I just want to use a sample application. I'm not going to upload my code, right, from either S3 or a local file. I'm just going to use a sample application, okay? So I'm going to create the application. Now, notice that I didn't click any configuration options. I just said, you know what? Just do it. And guess what it's doing? Without answering any questions, it's basically just creating an environment for this sample app. Now hold on for a second, because I want to show you another way to do that. Okay, let's say I go back. I'm also going to do Java again. I'm just going to stick with the recommendations. This time I'm going to configure more options. Here are all the questions that you could answer about, do you want X-ray enabled? Do you want to rotate logs? Do you want some log streaming? What kind of instances do you want? Do you want to change the way the containers run inside these instances? Is this a single instance? See how these are T2 micros and T smalls? In other words, the configuration doesn't have a load balancer, but it could. I don't have any rolling update policies. I haven't done anything with security. Do you get the sense there's some decent amount of options here? There are. It's not everything. This is why this is limited. You can only do relatively simple architectures with this, but it does have options, like for creating a database if you want it, or, adding up a load balancer and setting up auto scaling and all kinds of stuff, right? So, and by the way, that's only for single instance. Watch this. I'm going to switch to high availability, and notice I can use spot and on-demand instances if I want to. I'm just going to switch to high availability for a second. Now, what will happen is that all of a sudden, load balancer comes up live, right? It changes the parameters that are available down here based on what I chose upstairs. I can create a fleet using spot and on-demand instances. My point being is that these are all the questions that it could potentially answer for you. And by the way, there's another set past environment into applications and other pieces that you can look at. So this is a wizard for launching containers and EC2 instances and containers on EC2 instances in a very kind of like wizardy kind of way where it answers questions and it applies best practices. Remember, this is relatively limited. It's not going to do infrastructure as code, but it's a great place to start, especially if you don't have infrastructure chops. Okay. I'm kind of like curious now as to like, hey, what are you doing? You're in a pending state. Yeah, this should be a bad gateway. You shouldn't do anything at this point. We'll come check on this in a second. All right. Questions about Beanstalk? Okay. Knowledge check. DevOps is a methodology that requires collaboration between all the teams involved in a product. True or false? Yeah, it's true. DevOps asks that everybody collaborates on the same goal, delivering software. Nearly all release processes can be simplified down to 5 stages: source, build, test, production, and monitor. I'm going to change one word just so you know. It shouldn't say test, production, monitor. It should say test, deploy, monitor. But that's an oversight on their part. Production could be another word for it, right? So that's true. When did production become a verb? Okay, DNS cutover and swapping auto scaling groups are the 2 most common methods to reroute traffic in a blue-green deployment. Is that true? If I want to cut over traffic, does those 2 methods work? Yes. Good. All right, last 3 questions. AWS CodeStar compiles source code, runs tests, and produces software packages that are ready to deploy. Is that what CodeStar does? Remember correctly, CodeStar was at the top of the build chain, right? It wasn't part of the build process. So oddly enough, code build is what's used for that. CodeStar just sets up projects to use those pipelines. Code build is the name of the software that does the building. All right. With Elastic Beanstalk, new versions of your app can be released on an existing stack in a rolling update. Is that true? Can you do a rolling in-place update with Beanstalk? Yeah, you can do that. No problem. Okay, last but not least, in AB, the deployment strategy works very differently from a blue-green deployment strategy. Is AB a whole lot different than blue-green? Is that true or false? Okay, so let me make sure I'm clear. In blue-green, you have 2 environments. One has 100%, one has 0. You swap the percentage of traffic. So you go from 0 over here to 100, right? In A/B testing, you've got 100% of your traffic. You take 5% and put it over here, 95 is over here, and then you cut over. It's not that much different, actually. So 2 environments are still in play. Huge amount of traffic all of a sudden gets cut over. That's A/B testing, or well, it's also sometimes known as canary. So false. It actually is. They are remarkably similar. Just a small percentage of traffic difference. Okay. Should we take a break? We want to take a break before we get to this last little piece. It's been about 90 minutes. Sounds good, right? All right, so let's take a short 15-minute break. So it's 2:25 now. Let's come back at 2:40. When you come back, I'm going to talk about the scenario, get you started on your lab. I'm going to give you the evaluation for the course. Actually, I also probably need to run through the wrap up. So I'll run through the wrap up too. Then we'll get started with the lab and then we'll finish. Okay, so go take a break, a true 15 minutes. So come back at like 2:41. I'll put up a timer since I was talking for a minute. Okay, so we'll see you in a bit.